Hello everyone, welcome to Zarab Game Dev. In this video, I'm going to be creating the StickHero game in Unity. So it's just a pretty basic game. You may have already played it before. So there's a player and it's positioned on a platform and it has a stick in front of it. And when we click the screen, the stick starts growing. And when we release that touch or the click, the stick will fall, and if it does not fall on the platform, will die. And if it falls on the next platform, then the game should be able to continue. So before starting, if you do like my video and have any suggestions for what video should I make, and if you do like this video, so do like and subscribe to my channel and do comment if you want. So whatever you want to comment, just suggest it and it will help the video push more to other viewers. So that's how the YouTube algorithm works. So if the video reaches more, then the views and everything will be more. So if you can do that, thank you. If you can't, then no problem, you can just watch the video and I have fun. So let's start creating the game. So I have the basic scene setup and deleted the sample scene and added the new gameplay scene. And the text mesh pro, I've added the score, so it automatically installed that package. I already imported the sprites, and if you wanted, you can get it for always from the GitHub link, which I'll be posting in the video description. And I already added all the scripts, so there are not much scripts. One's for the game managers, the second one's for the state manager, and there's for diamond and the destructor. So as we'll go through the video, you should be able to see what each of the scripts are going to do. Next up, we'll have something for the prefabs folder. So let's start creating our scene. So the first thing we'll create is, let's add our score because it's always going to be visible, and whatever we'll do, the score will always be there. And let's set it to 0 0, and let's increase the size to 160, and if we position it towards the top, and let's have it -0 and -150. Let's increases it to 500 and size to 200. Let's have it positioned towards the center, and 160 is also already too less. Let's make it 256, and we'll increase the width to 800 and height to 300. Let's make it bold, and we'll position it -250. So that's how our score is looking for now. And let's set up a color for the canvas. So let's use the, which color should we use? Let's use a blue color. So 9B F6 FF. So let's see what it will convert to. 9B F6 to 55 minus 11 and FF. So that's how it's going to look. It's almost pretty much blue, but it won't matter. And now let's have our score. So the first one is the 1, the second one is 16, which should be translate to 16 plus 6, 22, and the last one is 27. So let's do 32 plus 7. So that's our score count color. And after having our score count, let's create our start text. So the start text is nothing but just a button, and we'll have a title attached to it. So let's create a UI and not an image. Let's delete it, and let's create, what if we change the portrait high. Hmm. And let's set our canvas size to be 1080 by 1920. It's looking a little bit larger. Yep, let it remain as it is. and we'll set it to 1170 2535. So let's create a UI text mesh pro button, and we'll just call it start button, and it's going to have our play, and let's set it to native size and we'll resize it. So let's make it 500 by 500, and the only text it's going to say is let's hide our score. So it's just going to say the StickHero text. So let's delete this text and we'll add a new text to it, and let's have the transition set to none. We'll position it around maybe 250, and let's add a UI text mesh pro, and we'll just call it title. And for the title it's just saying the stick hero, and let's make it bold 160. The size is going to be of our score color, so let's pick that color and we'll increase its size. So instead of 200, let's make it 800, and center and the center, and spacing options line, let's increase to 15, 20, and character, let's have it a little bit more spreaded. Similarly, let's have it at 20, and we'll position it a little bit towards the top. So let's position it at 500, and we already made it bold, so there is no need for anything else. And the stars better be at 0, 100, and let's set up the title a little bit higher, 750. So let's have it there, and we'll hide our score text because it's not going to show up in the start. And we have our main camera set to 8, and let's position our main camera correctly. So it's just a little bit 2 and 3, nothing else. And now that's how our screen's going to show when we start. And let's set our main color to white. So what goes with red? Blue, but we don't want the blue color. Let's have it green. Green's also ugly. How would purple look? Yep, nothing looks better. Let's have it to white only. So after having the start panel, let's add a panel for our diamond. So it's an image. So let's add an image and we'll call it diamond, and let's position it 0 0, and let's set the image as our diamond. Let's set it to native size, which is already does not matter. The diamond is 100 by 100, or have we set it to 100? Hmm. Let's have it 150 by 150 with the color of the red, and we'll position it towards the top right. -75 and -75. So that's where our diamond's going to be, and let's attach a text to it, which is the diamond count, and it's just going to say 00 for now. Let's set up its color to black, and it's going to be positioned from the -150. Let's increase the size to 96 volt, and we'll position it towards the center and center, and instead of -150, -75 should suffice. And let's increase the size to 128. So 128 looks better, and let's position a little bit towards the left, and we'll increase the size to 400. So that's how our diamond's looking for now, and there's no need to hide the diamond, but we'll hide the start text and we'll show the score text. And now the last thing we'll need to create is an image, and it's going to spread across the whole screen. Let's make it white and let's have it a decrease transparency. So let's set up the color to be this black color, and similarly it's having a decreased transparency, and let's attach an end panel to it. So we have our end panel, and now after having our end panel, let's attach a text first, which is just going to say the end text, or it's just going to say game over. Let's make it 160, increase the size to 800, centered and bold, and white will be pretty much better here, and we'll position a little bit towards the top, maybe around 750 or 650, not 6. So it's just going to call the game over, and yep, 750 would be better. And we need to hide the score, so there's a game over. And after having our game over, let's create one more image, and this one's going to be pretty much whitish, 1000 by 1000. And as you can see, it's positioned perfectly at the center, and it's going to show our score. So if we change the text color to black, and doesn't look like it will like it, but let's have it set to white, and here we'll have our score. So let's call it score holder. So it will have two scores. So let's create a UI text, not a text. We'll need a text mesh pro. So let's create a UI text mesh pro, and the first one is the score, and it's just going to call the score with a bold with the color of the black one, position towards the center, and size increase to 96, width to 1000, and it's already bold, so there's no need to do anything. And what we'll need to do now, 128, nope, 96 will suffice. So it's already created 96, and now we'll attach one more score, which is going to be the score count, and it's just going to be 00. Everything's going to be similar as the previous one, and let's make it bold, position towards the center, but it's going to be from the bottom, and let's have it 100, 150, 200, 175, and let's attach the 125. So that's how our score is looking, and let's increase the size to 128. So it looks better, and let's rename this as the best score, and similarly we'll rename the score count to be best score count. And similarly, instead of score, it's just going to call the best. And first, let's position the score at 250, 350, and similarly, the best going to position at negative 250 or maybe 150. So it shows our score correctly, and let's position this one a little bit down and this one a little bit upwards, negative 100. So these are showing our scores, and after showing our scores we'll create two buttons. So it's going to be button text mesh pro, and let's call it restart, and restart is going to restart the scene. Let's delete this text and let's set up it as the restart. Let's set it to native size and we'll increase its size to 250 by 250. And as you can see, we'll position it towards the bottom by -5, 800, and x by 250. And we'll duplicate the restart, rename it to home, and instead of positive 250, it will be positioned at -250, and UI we are going to use is the home UI. So that should do it for our end panel. And that's how our scene's looking for now. And let's highlight our scores. So we have almost completed the canvas. So let's create two empty. The first one's for the game manager, and the second one's for the state manager. And let's reset both its transform, and let's attach the game manager component to the game manager and the state manager component to the state manager. So it should do the trick. Now after we have both our components, let's create platform, the hero, and the stick. So the hero is going to be called the player, the stick is going to be called the stick, and the platform is going to be called the platform. So let's position our platform at -4, the player at -2.8, and similarly the stick is going to be positioned at -2 point, negative maybe 3. Mm, 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 mm. And let's position it more appropriately. Okay, so -3 is fine, and we'll just have it as 0.1 or maybe 0.4, and set our player to be 0.1. So these are three prefabs we are going to use, and let's also create our diamond. So we'll change the diamond color to be red. So that's how our diamond is looking. And we'll also attach red to the platform. So where's the red? I don't know. 4, 0. Okay, so there's a red, and if we position it around 0.4, maybe around 1, 0.9, so that should be a red. I'm just going to use it as a decoration for now because it's not going to have anything else. And our diamond should work correctly. We'll increase the stick size to 2 and Y size to 0.5, or maybe 2 will also suffice. So the first prefab, let's create of our diamond. We have already its transform set to 0. Let's position it -2.5, and let's rescale it 0.8, and it will always collide with the player, and if it doesn't, maybe doesn't matter. And let's create a tag. So the first tag we are going to create is for the diamond, and the second tag we'll use for the platform, and we'll attach the tag of diamond to the diamond. And afterwards, let's attach a box collider 2D and a rigid body 2D, because we are going to attach the script to the diamond, so it needs to be have a rigid body to detect collisions, because the simulated activates this colliders to detect, not the other way around. If we just add a box collider to any other object, we should be able to detect which has a rigid body. And it's already set up correctly. Let's add the diamond and the distance distractor script to it. So that should do all the trick. and we'll save the diamond as a prefab. And let's delete the diamond, and let's create our two empty, which are the rotations in the z by -90, which is going to be a rotation for the stick, and we'll duplicate it, renaming it to 180, and we'll just set up the rotation to be -180, and let's delete the 90. So we have our stick. Let's reset our stick size, so let's have it 1. So next step, let's set up our player. So it's just going to be a similar object. Let's set its tag to player, and it's not going to have anything additional. And the sprite is already set up. We'll need to attach a box collider 2D. And why does it have a distance destructor script? It's not going to have any script, but we'll check afterwards if we'll need to attach a rigid body to it, because this one's just going to send the triggers, not check for the triggers. So maybe it won't be necessary. And let's position it at 0, because we are going to calculate it afterwards. We'll need the y positions, so it will be necessary to have our y position. So that should be it for the player, and we'll save the player as a prefab. And the next, let's have the stick, because similarly it's also pretty much easy. And we have the position, the scale, the sprite, and it's not going to detect any collisions, so we also won't need a tag. Let's position it at 0 for now, and we'll change the position afterwards. But order in layer will be higher, because we'll need to show it. Or maybe let's set it to 0. Maybe we won't need to show it. The scale will set it to 0.2. For now it's not showing up, but we'll change it afterwards. And let's attach the distance destructor script, because will uh, it will be dereferenced whenever a new stick will be spawned, and we want it to be destroyed whenever the player reaches a certain position. So the stick is correctly set up. Similarly, we'll save the stick as a prefab, and here inside let's position it 0.4, and we'll increase the 6 ties to 1. So that's how our stick's looking for now. And the last thing we'll need is the platform. So the platform is already positioned correctly, but similarly it will need a couple of things, which is just the box collider 2D and the distance destructor. So let's attach the box collider 2D. We'll need to set it as a trigger and set the tag as a platform, because whenever the player reaches the end, we'll do a physics raycast to check if we are standing on a platform. And let's attach the distance destructor script. So it will get destroyed whenever it reaches a certain distance from the player. And that should be it for our prefabs. And whenever we'll need to use or check it, we'll just attach the script here. So let's delete our diamond. We have our basic scene setup. So we'll create everything from the game and the state manager. And everything else remaining is just the coding part. So which will create step by step. First, we'll create the platforms, or should we use the UI first? Start is just going to start the function, diamond, and the end panel. Let's just open everything up, and everything's opened up, and let's start creating our script. So let's open our game manager script. So let's go inside Visual Studio, and let's see what we need to do. So let's create our state manager. So the state manager is just going to persist between scenes. So whenever the scene is restarted, it's just going to store a boolean, and to store it we'll need a public static reference. So public static state manager instance, and we'll set it up in the awake function. If instance is equals to null, then instance is equals to this, then we'll do don't destroy and load game object, else destroy the game object, and we'll create the public bool as scene started. And if we have started it, so has scene started is equals to false, and that should wait for our state. And inside the diamond it's just going to have on trigger enter 2D, and if collision dot compare tag, and it's going to collide with a player, then we'll destroy the game object, and we'll call the function from the game manager, which is the game manager dot update diamond. So that should be it. And let's also create our distance destructor. So the distance destructor is just going to get a reference to the player, and we'll check its x offset, and if it goes beyond a certain range we'll destroy the current game object on which the distance destructor is attached. So let's do that. First it will have a reference to the private game object, and let's just call it player. And let's just call it in the start. Player is equals to game manager dot find. There is only game, not game manager dot find, game object dot find, and we'll find the player. And inside the update, we'll check if we don't have the player, then player is equals to game object dot find, and we'll search for the player, then we'll return, and in the next frame we'll check if player dot transform dot position dot x minus transform dot position dot x is greater than 15f, and we'll just destroy the game object, and nothing else will be needed. So that should do the trick, and everything else we are going to do it inside the game manager. So let's see what we'll need. So let's create the enum which we'll use. So let's call it game state, and it's going to have multiple states. The first one, which is the start, which is the start state. Next one is the input, then the growing state, in which we will detect if it is pressed, and none because none other states are needed. And let's create our game manager instance class. It's just going to be called from the diamond to update the diamonds, but let's just create it, and we'll set it up. If instance is equals to null, then we'll set instance is equals to this, else we'll destroy the game object. And there's so many things to be done. Mm, 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 mm. So we have our instance set up. Now, let's create all the variables. So I'm just going to dump it here because I've already done it before and I know what it will need. So the first one is a serialized field, private vector 3, start pause, and it's always going to start from 0. And next we have a serialized field, private vector 2, and here we'll have the min max range for which spawn range, the width of the platform, and the spawn range is just going to check how much further we are going to spawn from the start position. And offset will just calculate it depending on the spawn range. And then let's create a serialized field for the private game object, and here we'll have every object. So let's create pillar prefab because it looks like a pillar, and we'll have a player prefab, stick prefab, the diamond prefab, and the current camera. And rotate transform and the end rotate transform. And let's create a serialized field, private game object, and let's have our score panel, the start panel, and the end panel. The diamonds are always going to be shown, and similarly we'll need to attach the respective text, so we'll need to use the using TM Pro. And again, this one's going to be serialized field, private TMP text. And the first text is for the score text, score and text. Diamonds text, and the last one will be for the high score text. And that should be it. Then we'll need a couple of variables to store. So private game object, current pillar, next pillar, the current stick, and the player. And private integer for the score, the diamonds, the high score, and nothing else. And one more private float, and this one is going to be for the camera offset X. And private state, private game state, and let's just call it current state. And that should do for all our variables. And there's two more: serialized field, private float, and the first one is the stick increase speed, and the max stick size, which is going to be the Y size. So that should do the trick. And I think we have everything. So let's just attach it inside the Unity so it won't show errors later. So let's attach a pillar. So the first one's the pillar prefab, which is the platform. Next one's the player. And then we have the stick, then we have the diamond, then we have our current camera, the start rotate transform, and 180 is the end rotate transform. Then we have our score panel, the start, which is the button, and then we have our end panel. And let's set up all the text. The first one is the score text. The next we have the score and text, which is score count, the diamonds text, which is the diamond count, and the high score text, which is the base score count. Stick increase size, and the max stick size is going to be set to 5. The spawn range is set to from 0.8 and 3, and the min max range, uh, so let's set it to 0. Maybe 6 and 4. 4 should be fine. And the start pose is always going to start at 0. Now, next up, we'll need to spawn the objects at the starting position. So, we'll need to attach a functionality for the start. So, let's go inside Visual Studio and let's set up the awake function where we are going to almost do everything. So, the current state is going to be the start state, and let's do end panel dot set active to false for panel dot set active to false, and the start panel dot set active to false. Hmm, hmm, hmm. The score is going to be 0, and diamonds are going to be player prefs dot has key, and let's get the diamonds key. And if it has, then we'll get the player prefs dot get int, and we'll get the diamonds. Else we'll just set it to 0. Okay, it's just the semicolon. And here instead of diamond, we'll just go for the high score. And instead of diamonds, it's just going to call the high score. And let's set up the text. So the first thing we'll do, score text dot text is going to be score dot toString. Diamonds text dot text is going to be diamonds dot toString, and high score text, let's just set it up, high score dot toString. So after having everything, we'll need to spawn the objects. So let's create a void create start objects. It's going to be parameterless, and we'll create the start objects. And after creating the start objects, if the state manager dot instance dot has seen started or has seen restarted, let's just call it has seen started, then we'll call the game start function and we'll call it afterwards. So inside the create start objects, we'll need to create the platform. Where should we start? Let's create the helper functions first. So it's going to start the objects. We'll go in the reverse. So let's create our helper function first. So helper functions. So the first function we are going to create is enumerator, and it's just going to move. And the parameters we are going to pass is the transform, which is called the current transform, and v3 target, and float time. And let's call that past is equals to 0f, where init is equals to current transform dot position, and while past is less than time, with first year return null. So it's going to call at every frame. We'll set the past plus is equals to time dot delta time, and where normalized past divided by time, and v3 dot lerp, and we are going to lerp from init, and let's set it to target, and with the normalized ratio, and current transform. So that should do the trick, and we'll copy this one more time, and here instead of move, it's just going to call rotate, and we are going to pass a vector 3. Past in it, similarly, it's going to be same, but instead of v3.lerp, it will have quaternion.lerp, and instead of lerp, use slurp. In the init, let's use rotation, and that should be it for the rotation. And instead of position, we'll use the rotation. So these are two helper functions, and after that, let's create a public void scene restart, load scene 0, and inside the state manager, as scene started will be set to true because we are restarting the scene. Let's duplicate this, and instead of scene restart, we'll call the game restart, and it's going to set from false. And next, we'll have the game start function. So public void, and inside the game start function, we'll stop showing the start panel and we'll show the score panel. And then we'll create a platform. So it's going to be a void, let's create a platform, and after creating the platform, uh, we'll need to create one more function, void set random size, and it's going to have a parameter of game object, and let's call it pillar. Mm, 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 mm. So we'll create a platform, and we'll set random size for the next pillar. And afterwards, we'll set the game state to input. So that should do the trick. We don't have any but functions yet. And let's update. Before updating our set random size, we'll need to update. Maybe let's just update our set random size. So we'll need allowed scale, and inside our allowed scale, use next pillar dot transform dot position dot x minus current pillar dot transform dot position dot x. Then we'll subtract the next current pillar dot transform dot scale dot x multiply by 0.5f, and again we'll subtract 0.4f, and afterwards we'll say new scale dot x is equals to mathf dot max. We'll need maximum for the 2 points. First one is the min max range dot x, and next we are going to calculate random dot range, and here we are going to pass min max range dot x, and the second parameter mathf dot minimum. Allowed scale else min max range dot y. So if the allowed scale is larger, then we'll use the min max range dot y. But if the allowed scale is small, if the allowed scale is small, it will use our allowed scale, and in that it will trigger our min max range to be something less than the minimum range, and it will choose the maximum, which is the min max. So that should do the trick. And let's go inside the update or the create platform. So inside the create platform, let's use var, and let's just call it current platform. And what we are going to do is instantiate the pillar prefab, and we'll set the current pillar to be the next pillar, and for that next pillar should be equal to null. So if next pillar is equals to null, we'll set the current pillar to be the current platform, else we'll set it to the next pillar. Hmm, hmm, hmm. And the next pillar is going to be the current platform. So we'll set the current pillar to be the next pillar. And the next pillar which we are going to set is going to be a new platform. So that should do the trick. And afterwards, we'll need to set the current platform dot transform dot position is going to be pillar prefab dot transform dot position plus start pose. So that should be it. And let's create a temporary distance, and here we'll use a new vector 3, and inside the vector 3 it's normally going to be 0 and 0, but for the expose we are going to get random dot range from spawn range dot x and spawn range dot y. And after that we'll need to have the current pillar dot transform dot scale dot x into 0.5f. So this will set up our next distance, and that should be it for our create platform. Now let's set the create start object. So the first thing we are going to do is create platform, and after creating the platform we'll say v3 player position is equals to player prefab dot transform dot position, and player pose plus is equals to current pillar dot transform dot scale dot x into 0.5f minus um, 0.35f. Current pillar dot transform dot player pause x. Hmm, hmm, hmm. And set the player to be the instantiate the player prefab, and after instantiating the player prefab let's instantiate at the player post quaternion dot identity, and the player dot name we need to set its name to player. So that should be it for the player. Now after spawning our player, similarly we need to spawn the stick. So let's create a vector 3 stick calls, and instead of doesn't stick prefab dot transform dot position. Current pillar transform dot scale dot x into 0.5f minus 0.05f. And similarly, we'll set the current stick to be instantiate the stick prefab at the stick position quaternion dot id. And that should do the trick. And if we have done everything correctly, it should not have any problems. So let's create the rest of the functions first. Mm, mm, mm. So the first function is the void update score. Score plus plus score dot text. Score text dot text is equals to score dot toString. And similarly, let's create a public void update diamonds plus plus diamonds text dot text is equals to diamonds dot toString. And let's set the player prefs dot second diamonds to diamonds. Hmm, hmm, hmm. And let's also set up the game over function. And it's just going to be called from here, so there's no need to make it public. So let's create the game over, and inside our game over, we'll show the end panel and we'll hide our score panel. And after that, we'll check for the score increase. If score is greater than high score, we set the high score to be score player press second score and text dot text is equals to score dot toString, and high score text dot text is equals to. So that should wait for our game over. And create objects is also perfect. Random size, create platform. Then we'll call the game start function. So let me check. We'll need to set up our offset. So after creating our start objects, let's set up our offset. So camera offset x is going to be the current camera dot transform dot position dot x minus player dot transform dot position dot x. Hmm, hmm, hmm. So let's check if everything is correct. So we have our update score, the update diamond, the game over, create start objects, the create platform, which will spawn a new platform, and it's just have the diamond remaining. So let's just add it. If random dot range from, let's give it a 10% chance is equals to 0, then temporary diamond is going to be instantiate the diamond prefab. After that, current platform dot transform dot position, then tempos dot y is going to be diamond prefab dot transform dot position dot y, and temporary diamond dot transform dot position is going to be the temp. So that should do the trick for our diamond. and it has already attached the diamond script. So we'll just call the game manager dot instance dot update diamonds function. And our distance destructor should also work, state manager should also work, and the last thing remaining would be attach all the scripts to the buttons. So let's see how much we have coded for the game manager. 100 lines of code around should be remaining. We have a rotate, move, scene restart, quit, start, create platforms, set random size, and create start objects, game over, update score, and the diamonds. And now the last thing remaining is the hmm hmm. So let's go inside Unity and let's see if we are having any errors. Assigned but not used doesn't matter. Was I inside Visual Studio when I recorded everything? I don't know. Maybe I need to check afterwards. So let's hit play. And as you can see, it's false. Okay, okay. So start panel dot set actor needs to be true. And let's attach the start functionality. So let's have the game manager and it's going to call the game start function. And let's hit play. So it should spawn an object and everything is working almost correctly. And let's attach the restart and it's going to restart the scene, which is the scene restart, and the home, it's just going to restart the uh, what do you call it as reload the scene, so it's going to be game start. And there are not any problems for now, but now let's see if everything is working correctly. So if we hit play, it should show up our gameplay, and we already have our diamonds, so let's create something to set up the input. So let's go inside Visual Studio, and I really need to check if I didn't screw that up or I'm not going to record it. If somebody is watching and I didn't record that, you can follow up from my GitHub link. And maybe I didn't, but maybe I did. I'll know it afterwards. So we are already inside the Visual Studio and let's create the update function. And everything inside the update function, it's going to work if first we have the current state to be the input. If we are inside the input state, then if we input dot get mouse button of 0, then we set the current state to be the growing state, and we'll call the scale stick function. So let's call the void scale stick, and inside the scale stick, which we are going to scale the current stick, so let's create a vector3 temporary scale, and it's going to be current stick dot transform dot scale temporary scale dot y plus is equals to time dot delta time into stick increase speed. And if temporary scale dot y is greater than max stick size, then temporary scale dot y is equals to max stick size. And we'll set the current stick dot transform dot scale to be the temporary scale which we have created. So scale the stick once, and afterwards if current state is equals to growing state, and if input dot get mouse button of 0, and if we have already pressed, then we'll scale the stick, else if we have not pressed, it means we have released the stick. So we'll enumerator, and let's call it false stick. And for now, let's have it a yield return null. So we'll start the coroutine for the false stick. So let's go inside Unity and let's see if our stick is scaling. And if we hit play, and if we click, our stick is going to the max size, and afterwards what we'll need is rotate it 90 degrees, move the player across the whole stick, then move it across the platform, then we'll move the camera over, and already if it is valid, as if we are failing, we'll move the stick. Then first thing we are going to do is move the stick, then we'll move the player, and then we'll check if the player is falling or it is going to move across the platform. So let's do it. So let's go inside Visual Studio, and we already created all the coroutines for that, so it's just going to be some, not too much long, but somewhat long type of script. So the first thing we'll need to do is set the current state to be null, because we don't need to have anything, not null but none. And afterwards we'll need to rotate the stick, so we are going to rotate the current stick, and we are going to rotate by the rotate transform and 0.4f. And instead of current stick, we are going to pass the current stick dot transform, and we'll yield return x. So that should do the rotating part. Now after we have move position, current stick dot transform dot position plus new vector 3, current stick dot transform dot scale dot y 0 and 0, and move pose dot y is going to be the player dot transform position dot y. And similarly, we'll set the x to be the move, and here we'll pass the player dot transform, and we are going to go toward the move position, and the time, let's set it to be 0. So the player will move there, then we'll do yield return x, and afterwards what we'll do, let's get the results, and it's going to be physics 2d dot raycast all, and player dot transform dot position down, and let's create one more, which is the result, and instead of raycast all, it's just going to do the raycast. For each where tab and results, we'll check if it collides with a platform. If temp.collider dot compare tag, then we'll set the result to be that platform. Hmm. And after doing this, if we do not have the result, or result.collider.compare tag, and we are going to compare the platform tag, then we'll do the game over. So player.getComponent, and let's get its rigid body component, and we'll set the gravity scale to be 1. So it will fall down. X is going to be rotate. We'll rotate the current stick to end rotate transform and in 0.5f. And we'll do yield return x, and we'll call the game over function. And instead of current stick, we'll need to pass the current stick dot transform. Else, so this will end the game. Else, the first thing we'll do is update the score because we are rotated correctly. Then we'll need to move the player. So the move position, player dot transform dot position. Hmm. So the player is already moved. Now we are moving the player at the end of the current platform. So move position dot x is going to be next pillar dot transform dot position dot x, and we'll add the next pillar dot transform dot scale dot x into 0.5f minus 0.35f, and we'll do x is going to move the player dot transform to the move position, and let's do it in 0.2f. So wherever it may be, it will get finished at 0.2f. And we'll do yield return x, and after that we'll need to move the camera. Hmm, hmm, hmm. So the move position is going to be the current camera dot transform dot position. Move position dot x is going to be player dot transform dot position dot x plus camera offset x. So that should do the trick. Similarly, we'll call x move for the current camera dot transform towards the move position, and it will move inside the point, and we'll do the year return x, and after that we'll create a platform, then we'll set random size to the next pillar, and we'll need to update the state to input, and after updating the state to input, let's create the stick position, So the stick position is going to be the current pillar dot transform dot position, and stick position dot x plus is equals to not current pillar dot transform dot position. Hmm, hmm, hmm. Current pillar dot transform dot scale dot x into 0.5f minus 0.05, and we'll do stick position dot y and z. And let's copy this again, and instead of y we are going to use the z coordinate, and we'll need to instantiate and get a reference. So we'll set the current state to be the instantiate, and we are instantiating the stick prefab. Where is our stick prefab? At the stick position at identity. So everything should be finished and it's already inside Visual Studio, and let's go check our game. So if there are not many problems, we should be able to see. So there is no rigid body. Okay, so we have not attached a rigid body to the player. So let's attach a rigid body, and we'll set the gravity scale to 0. So now our game should work. If we hit play, we are moving, the game is getting finished. Home, 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 home. Okay, 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 okay. So restart has the scene restart, and home has the game. Okay, home has the game start. It needs to have the game restart. So let's hit play, and if we lose, we should have our home, and the restart is also working. So let's see. Oh no, we'll get the diamonds later, so that should not pose any problems. And as you can see, everything's working correctly. We have our score increased, we have our diamonds, and that should do the diamond trick. And next up, the last thing, I think the game is pretty much finished. So as you can see, we have created the game, and that's how the game is working for now, and that should be it for this game. So if you did like the video, do like and comment. So comment anything you like, and if you have any suggestions for any more some mini games, so almost I'll be doing around 15 games for this playlist, so 10 are completed, and next up there's going to be around 5 which will have a little bit of special effects and sound, and next one will be a complete playlist for all the complete games. So we'll be going from ads to the shop system and having all our scene correctly. And that should be it for this video. So if you watch the whole video, thank you for watching, and do subscribe the channel, and see you guys in the next video. And if I did forget to record that, don't blame me. You would already have the reference to the GitHub link. So thank you for watching.